Good afternoon. This is Group 9's Maths188 video tutorial on continued fractions. Continued fractions are a mathematical object constructed by taking the sum of an integer and the reciprocal of another number, then writing this other number as a sum of its integer part and another reciprocal, and repeating the process. This is useful as it can provide a good approximation to any real number and contains several desirable properties. These fractions can also be concisely represented by tuples, which will yield a unique pattern for each and every rational real number. Irrational numbers are represented by infinite continued fractions and allow for good approximation of irrational numbers to be made by stopping the continued fraction when the integer is very large. This is easily seen when representing the infinite continued fraction in tuple form. A visual representation of a finite continued fraction is shown to the left, where n is a non-negative integer, a1 is an integer, and ai is a positive integer, for I equals 1 to n. The right diagram shows an example on finding the continued fraction form of a real rational number, 3.245. It's hard to pinpoint the origin of continued fractions, since it's appeared in the last 2,000 years of mathematics. The first major example of continued fractions occurred in Elucid's The Elements, as a byproduct of his algorithm for finding the greatest common divisor. It has been steadily found more and more as time went on, with major implications of continued fractions being discovered in the last 500 years. Examples include Johann Lambert in 1761 gave the first proof of the irrationality of pi using a continued fraction for tan x, which is seen in the picture to the right. Some other examples of continued fractions is in 1770 when Lagrange stated and proved that any quadratic irrational number has a continued fraction expansion which is periodic from some point onwards. One area that continued fractions contributed to is number theory, by being used to create several factoring algorithms which is used in cryptography. The use of continued fractions in cryptography dates back to the late 80s and covers the introduction of algorithms used, the study of pseudo-random generator security, and the cryptanalysis of RSA algorithms. This algorithm can be adapted to different needs. For instance, in pay-per-view videos, expensive attacks on stream ciphers are not current. This algorithm can also improve the safety of communications between servers and clients. Further study in the future can be used to find best irrationals which can be used in this algorithm. Likewise, it may prove useful to generalize some properties of classical continued fractions to generalize continued fractions. Further applications are listed below and are extremely interesting concepts that use continued fractions to solve. One of the most fascinating ones is Led Christian Heinz' planetarium, which he made in the 1600s. It consisted of a gear-regulated system where Saturn's motion signified by a 206-tooth gear and Earth's motion by a 7-tooth gear. This ratio is shown by the mass in the bottom right corner, where he estimated the years it would take for Saturn to orbit the Sun and made a gear ratio that would duplicate the planet's motion around the Sun. Other examples include the representation of musical scale and Earth's calendar. Thanks for listening to our group's presentation.